Hi, hello dear students, welcome to our channel Maths with Anindra. In this video, I am going to explain functions theorems. Let us have a discussion. The first theorem here. If f from A to B or f maps A to B and g from B to C are two 1-1 functions, then G circle f from A to C is also 1-1 function. So whenever f and g both are 1-1 function, we have to prove G circle f from A to C is also 1-1 function. Just a rough figure I am going to draw, dear students. So now the function f is defining from A to B. So in A set, you have to take the elements A1, A2, just general names. So f is defining from A to B. So whenever from A to B f is defining, in the elements of B should be in the form of f of A1, f of A2. I hope everyone understand. Next, G function is defining from B to C. So the elements in C set will be in the form of G of f of A1. Similarly, G of f of A2. So, but we have to prove G circle f defining from A to C. So how it will be, just I will show here. F is defining from A to B, comma, G is defining from B to C. That implies G circle f defining from A to C. See how it will be. G circle f means it is defining from G circle f. It is defining from A to C. So keep remember. So now in the figure also we need to remember. So G circle f is defining from, this is G circle f defining from A to C. So figure over, just f from A to B and G from B to C. That implies G circle f is defining from A to C. Let us consider whatever the elements we wrote here. Let A1, comma A2 belongs to A. F is 1-1, G is 1-1, they are saying, no? So since f from A to B is a function, one function. Therefore, f of a1 comma f of a2 belongs to B, since G is defining from B to C. So G of f of a1, G of f of a2 belongs to C. G of f of a1 means, by definition of composite function, we can write as G circle f of a1. Next, G circle f of a2. That means which are belongs to C set. Okay. Whatever in the figure, just I wrote there. They are asking to prove G circle f from A to C is 1 1. 1 1 on to definition, functions, basics, 2 marks questions, and 7 or 4 marks problems I explained in the video. Once go to the playlist, dear students. So first, to prove this theorem, what we have to do, like this figure, maximum try to draw, you will get the good impression to the examiner. So f from A to B, G from B to C, then G circle f from A to C. You can assume like this. Now consider G circle f of A1 is equal to G circle f of A2. So this implies that G of f of A1 is equal to G of f of A2. Since G is 1 1, 1 1 function means what I said, f is 1 1 means f of a1 equal to f of a2, that implies a1 equal to a2 we are writing. In the previous classes we discussed that. So here, since G is 1 1, functions are equal, their elements also equal. That means f of a1 is equal to f of a2. Okay, dear students. Next, again, since f is 1 1, this is very important step, dear students. So whenever f is 1 1, the functions are equal means their elements also equal. a1 equal to a2. So therefore, G circle f of a1 is equal to G circle f of a2. Whenever functions are equal, that implies elements are equal. Therefore, G circle f from A to C is 1 1. Hence proved. So first theorem over. I hope everyone understands, students. So this is the way. First, functions you have to write it. Diagram not compulsory. Better to draw. Elements, this is the way you can consider. Okay, dear students. Next we will move to onto function. So onto how to do that. That also we will discuss now. At a time, 3 theorems I am going to explain. Either individually they will ask, or combinedly they will ask. So second theorem. If f from A to B, comma G from B to C are 2 onto functions, then G circle f from A to C is also on 2. So in the previous question, is 1 question, dear students. So what we have to do? First, f from A to B, comma g from B to C. That implies that G circle F is defining from A to C. I already discussed with you how to do this. We have to prove G circle F from A to C is onto. So onto means, suppose F is onto means what we can say? Every element of B, there exists an element small a belongs to capital A such that f of A equal to B. This is the way you can prove that onto function. So, but function is not here f na, G circle F. So, since G from B to C is onto means first you take the element from the codomain. So, for all element of C there exists, for every element of C belongs to. So, C belongs to capital C such that, simple way I am writing, G of B is equal to C. Okay, dear students. C value how to get means this is the way. Next, F is defining from A to B is on to, there exists small b belongs to capital B such that f of A equal to B. So now consider, so these are the definitions now. Now consider so G of B equal to C. That implies G of B means what? F of A only, no? That implies G of F of A means G circle F of A equal to C. So that means for every element of C, for all small c belongs to capital C, there exists small a belongs to capital A such that G circle F of A is equal to C. Therefore, G circle F from A to C is on to. This is the way you can prove, dear students. Hence, proved. Okay, dear students. How they will ask these two questions combinedly, that I will explain. So, theorem 1 and theorem 2. So, in what way they will ask? This is the way they will ask, dear students. That also I am writing. if f from A to B, comma g from B to C are two bijections, then G circle F from A to C is also a bijection. So how to prove is, this theorem is there, no? G circle F from A to C is 1 1. This proof, that means theorem number 1 proof, theorem number 2, this proof. So first theorem and second theorem combined. The above theorems, don't write above theorems in the exam, dear students. In this theorem, what we need to write is, in step 1, this theorem we can prove. So you can take this one completely, you write it in step 1. Otherwise, take that theorem number 1, theorem number 2. So 1 and 2 combined. So step 1, theorem number 1. In step 2, theorem number 2. Theorem number 1 indicates G circle F from A to C is 1 1. Theorem number 2 is G circle F from A to C is on 2. Or on to or injection. So surjection, sorry. So in step 3, from 1 and 2, step 1, step 2, from 1 and 2, G circle F from A to C is bijection. So both the theorems combinedly, if you write, third theorem will come, dear students. I hope you understand. Slowly you can copy. Go through that channel. I will try to give that link for the functions, 2 marks questions, 7 marks questions. Lively I explained, not in the tab. Thank you all.